Hi,
Hey,
I'm Camden. This is Anthony,
that's correct.
and we are making the program game Gladiator. And this is kind of like what we have. So,
So we're just going to be going through some of the basic things that we've learned so far as we've taken this class and been making our game Gladiator.
yeah. So when we first started to go through, we made some stories. We of like how the game would go through. The one that we're going to be focusing on right now is the battle equations and how the battles would go through. So we wrote out the way that it would go, giving like the different outputs that the computer would give based on the based on the equation that it would run through. This was basically the equation that you would have a roll that would then add to your weapon, and it would minus the enemy armor, and then minus the enemy's health. This was changed a little bit, but from that equation, we added that into our player control, which gets the attacker stats and the defender stats and puts them in an int right here. Okay. And so that is in the player control. So at first what we did to make sure that everything would work properly is we had it run through a series of if statements, which just pretty much test to make sure that everything is valid and is working correctly. To make sure that because we couldn't allow negatives or anything crazy like that.
They were designed to make sure that we had the values that would work for the bounds that we want, and to make sure that we had the tests for our test matrix that we created for this function, for this equation, to make sure that they would come out with the same values that we got for our test matrix.
Yeah. And so for our equation, we had in our original brainstorming example, we had the defender stats plus the armor, and we have the attacker stats plus the weapon. And if it is less than 0, then they lose the health of -1. This is because we have it -1 because our health is based on, like in a Legend of Zelda game, where if you hit the character a certain number of times, that's how they lose health. They only need to be hit a number of times instead of having a hit point basis where they need to be hit to deplete that hit point. Okay. So,
and we also made a test for this function to make sure that it runs correctly. We will show that later in this presentation.
Mm-hmm.
Next, we'll talk about some more of our select statements. As you saw before with our if statements and the other one,
Mm-hmm.
we had those as one of those select statements, making sure that everything was valid, that we didn't have any improper inputs.
Speaking of valid, in this while loop, we checked for our menu view. We checked to see when people type the correct commands or not. When they don't type in a valid command, it runs through this while loop and creates the new line and outprints that it was invalid, unless, of course, what they type in is true. That then grabs all the statements that are available and puts you in the proper area and from another menu.
And yeah, so this is all ran in with a nice do while loop that is also in this class, right in the display function, which is the function we've created to basically run the whole class, run this whole view to make sure that it is on this view and decide when to go to another view. So in it, as long as this value, this Boolean value is false, it's going to run through and it's going to display the menu. It's going to go to that get choice function that we just talked about. It has the while loop in it. And it's going to if it is a valid, like Camden said, it's going to send that here. And then it will send it in this do action function that we will talk about in just a second. But if it's a Boolean function, and if that is true, then this while loop will be done. And it will go through at least once because it is a do while loop. And it will continue going as long as it's false to ensure that we have the result we want.
Okay. And so those choices that are available are, or at least depending on the menu you're on, for this help menu, when you select those are shown here. That if you type in like main, then it'll bring the main display, or action, and it'll display the main or the action, the display action, or the stats. It'll display your stats function, or play, which will do the whole run the game essentially. And if not, if you type in anything else, it'll say that it was invalid and you need to type in the right thing.
And all that is in this nice switch statement that you see here, just this nice little section that goes, and you're able to have a number of different values. You can have switch statement checking strings, integers, it's all sorts of stuff, just single characters. And it goes through checking each case, like Camden said. And then if it's one of the cases, it does that thing. And if it's in a case, and if there's a break, then it ends the switch statement. And it just goes through until it finds what's true.
Exactly. Okay. So then we have our test cases that we ran through. So this is testing the fight case. And
Here. So as you see, so we have our fight case, and it's just having the values that we said previously that needs to be there. For each test, we have our attacker stat, we have our weapon, our defender stat, our armor, and then we create a instance of the player control. And in that instance, we have all of these things set there, and we run it, putting it in the equation as you see here. And we have our expected result, and the whole idea of the test is to compare here if our expected result is equal to the result we actually got. And if so, then our test passes.
Mm-hmm. Okay.
And if you want to explain the other one below it, and then we'll run it.
Okay. So we put the healing process and the fight process in the same test thing just to make it easier for us. And this one, it runs through the parameters of the player, and so we have a fountain in the game which allows the player to heal. It's only a one-time thing, and so we have it so it overrides the max health of the player and gives them back their full health so they can go through the game. And this test function goes through and if the health is more or less than what is expected, then it produces and an error and things. Okay.
So now we will go and we will test these just to show you that they do what we want them to,
Mhm.
which is always nice.
Yeah. Let's see if we can find it. There we go.
are.
Look at that.
100% on both tests. Yay. So as you see, it has the errors, or we have them, and we have results if it's nice.
The results if it's correct, and the output and the result for the fight if it is incorrect. It gives you errors and things.
Okay, our test worked.
So it just worked out. Okay, and then in our gladiator function here, this is where we have our global public classes that are static, so that way they're global, so everything can access them, and they're rewritten, so everything else can be updated on the current situation of those classes.
Yeah, and these functions, they are connected with these global variables that, like Hamlin said, they are able to be used through the getter and setters for the whole game. They are created at the beginning of the game, and then they continue to be used being static, so they're using that same block of memory the entire time. When it's rewritten, or if there's a new instance, it's always using the same block of memory, so you never lose that or accidentally have two current rooms, because that would just be awkward.
Yeah, that would be same exact room. We also, oh man, where's it? Here. I have an instance of another value of this string here, where it gets your choice, and based on that choice, again, just brings you to what you typed in based on whatever menu you're at.
Yeah, so with that variable, there's a major difference between this variable and the global variables that we showed you in the Gladiator class. So like we said, with the Gladiator class, I mean, they're forever, they're always the same block of memory, and they just are from the start to the end of the game. And a major difference here is this one is not forever. It's just used when this individual function is called. It can only be used by things inside this function after this point. So up here, if we had any code, it couldn't use this variable because it doesn't know about it yet. And this variable also is just going with, like I said, this function, and is returned somewhere else and is a different amount of memory at that point.
Mm-hmm.
It's not the same memory no matter where it goes.
Okay. Then we have our character class, where many of these things, we have a lot of getter and setters in this particular one, because it gets let's see, for example, so because our game is based on a floor, on different floors and rooms. So you have X and Y because it's sort of like a tower. We have what, I guess X is up.
X is the vertical.
X is yeah. So Y would be the floor that you're on, and it would get that and then set that for where you're at as to what floor you're on. So if you're on floor, so if you've been on floor 1 and you move to a different location, it'll set it again that you are on floor 1, which means that you moved to the adjoined X location on that floor.
Yeah, it's set up just like a typical graph with our X and Y axis accordingly. And so, like Camden said, it has, so we're going and we're passing variables. We have two examples here. We have an example of a variable being passed by reference. And so that's with every setter. Every setter passes a variable by reference, meaning that it isn't necessarily creating a new block of memory. It's just taking that same exact variable and it is giving it to another place by its parameters. As you see here, the int y, although it's being called by a different name, is the same exact value as whatever is put in to the parameters. And it's able to be used here with that same value. And then there is passing by value, which is what any getter is. It is passing whatever you're getting by its value because it's simply returning it instead of going and transferring data through your parameters.
Okay. So,
have we done everything?
We're still okay. So now we can see. That was the thing because you guys can see us, we can't see you. But that's pretty much what we've been working on. So we got this really fun program going, and we're really excited. We like the way that's going, and we have a lot of different things that we're getting, and we're grabbing them all and putting them where they need to go as the user puts in their input, and we're giving them their output. So we're having a lot of fun with that.
And hopefully we'll have the game done so that you guys can test it out and tell us how you like it.
Yeah. So thank you, and bye.
See you.